Hey guys, so this is our first review lesson. It is on domain and range. It is a little long. I'm going to apologize now. Most of the lessons aren't this long, so sorry. All right, so what is a function? So I'm going to give you a different definition than what you're used to. This is more of a high-level definition. So let x and y be two non-empty sets. A function from x to y is a relation that associates each element of x exactly one element of y. I like giving definitions in calculus just because this is what you'll see in college, just to kind of prepare you for that. And remember, our domain is x and our range is y. All right, so the domain and range of these. So while I'm not asking you to graph them here, thinking about the graph is really helpful in my opinion. So in number one, what is that a graph of? That's a graph of a line. So a line is just all real numbers for the domain and range. You can plug anything out, you get everything else in. The domain for a square root, we can't have a negative, so the inside has to be greater than or equal to 0. So x plus 9 has to be greater than or equal to 0. So negative 9 to infinity. I usually do set notation. You can do an inequality if you want. That's just how I do it. And you can have 0 under a square root, so it's a bracket. And infinity is always a parentheses because you can't actually equal that. The range, if we plug in negative 9, what do we get? We get 0 minus 4, which is negative 4 to infinity. All right, domain. When you have a fraction or a rational function, you can't have 0 in the denominator, so it's all real numbers except x equals negative 5. Some people on their summer homework, I did notice, for those who came, did that. That's a double negative, so that means x can't equal 5. So put x equals all real numbers except x equals negative 5, or you could put all real numbers and x cannot equal negative 5. Don't put both. Your range, if you remember, the horizontal asymptote is not in the range. So if you take your x's and you divide them, you get 1. So this is all real numbers except y equals 1. All right, domain. So this one's a little tricky. There's two things here. The bottom can't equal 0. So 5 minus the square root of x equals 0. So x can't equal 25. But also the denominator has to be greater than 0 because of the square root. So this is 0 to 25 and then 25 to infinity because you can't actually equal 25. And then the range, if we plug in 0, we get negative 3 over 5. Wait. No, I'm blanking on this one. I think this is actually it's all real numbers. I feel like this is all real numbers. Now I'm blanking. I think it's all real numbers. I think this one works out. We'll look at the graph later and come back to this if we have to. All right, so this is a absolute value, so it's a v. It's an upside down v. Domain is all real numbers. The range, it's upside down because of the negative infinity to 2, the y value. Number 6, that's a quadratic, parabola, all real numbers. The range, we need the y value of the vertex, right, because it looks like that. So if we do negative b over 2a, so that's 2 over 6, which is 1/3. And then we plug the 1/3 in. 1 over 9 minus 2/3 plus 5. So that's 1/3 minus 2/3 plus 15/3 is 14/3. So it's 14/3 to infinity. All right, so a little bit more, just a few different problems. Same idea with this one. You can do negative b over 2a. You could also complete the square. I think that actually makes this easier. Minus 25 over 4. So our domain, all real numbers, our range, negative 25 over 4 to infinity. This one, denominator cannot equal 0, so all real numbers except x equals plus or minus 2. Our range is all real numbers. So when there's an x on top, it's typically all real numbers for that. Let's see, domain, the inside has to be greater than 0 or equal to, greater than or equal to 3t. T has to be less than or equal to 4/3. So it's negative infinity to 4/3. And the range is the square root, so it's going to be 0 to infinity. All right, this is the tricky one. So if I factor this, u plus 1, u minus 1, we need to figure out where this will be positive because the square root has to be positive. So this is something we're going to do a lot of. We make a chart. So to the right of 1 is 2, right? If I plug in 2, I get a positive number. If I plug in 0, I get a negative. If I plug in negative 2, we get a positive. So the domain is negative infinity to negative 1. We can't go from negative 1 to 1 because that will make the square root negative. So our domain, negative infinity to negative 1, 1 to infinity. Now, for the range of this, I'm not going to lie, I had to look this up. I could not remember how to do it. So when you talk about range, a lot of times you're kind of looking at what's happening when the numbers get really big. So if we ignore that negative 1, right, we get 5u over the square root of u squared. That's 5u over the absolute value of u. So what ends up happening is it's actually negative infinity to negative 5, and then 5 to infinity. I wouldn't expect you to do that without a calculator. That one's pretty hard. I had to look it up. I couldn't remember what it looked like. All right, these are the easy ones. Right. So we're just plugging in, right? F of negative 1. So if I plugged in negative 1 is this part, it's just 0. 100 is here, so that's the y value 10. And then 200, we're going to plug into the bottom one. So 0.2 times 200 minus 10, which is 40 minus 10, which is 30. That's it. Okay, so let's do a graph. I'm going to do it down here. So we've got 0. We're going up to 100. Let's extend that. And then this is 10. All right, so from less than 0, we're like that. We have a horizontal line. From 10 to 100, we also have a horizontal line at 10. When we plugged 100 in, we got 30. So 30 is, say, here. And it's just a line that's 1/5 x minus 10. So a slope of a fifth. That's it. All right, so the domain, all real numbers. The range, this is kind of weird. We have 0, 10, and then we have 30 to infinity, right? Because we're starting at 30, and then we're just going up. And then we have these random y values of 0 and 10. All right, our x-intercept is negative infinity to 0, right? That's our x-intercept. Our y-intercept is 0. Okay. All right, this one's a little nicer. This is more likely what we would see. So one thing you notice, it doesn't have arrows, The program that book creators use, it never puts arrows, but assume they're there. So my domain is all real numbers. My range, my lowest point is here, which is -3. And it goes on forever. Even though there's like these gaps here, you don't have to worry about it because it's over on this side. All right, so these are the problems that are probably the most important. In fact, I took this picture from an AP Calculus problem. So we're gonna look at pictures like this a lot this year. So f of -2, so that's just asking the y value, that's 3. F of 1 is 0. Is f of -4 positive or negative? So remember, it's talking about a y value. The y value is 1, so that's positive. For what value of x is f of x equals 0? So y is 0 at -1 and 1. X equals. For what value is f of x greater than 0? So that's above the x-axis. So that's -4 to -1, and that's it. Whenever you're talking about values like this, we're only ever going to put the x value. Don't put the y values. All right, a few more problems. The domain, that's -4 to 3. The range is -1 to 3. Lowest, highest. For what values of x is f increasing? So increasing. So the slope is positive. That is -4 to -2. And then it's, so here, right, increasing and then decreasing, decreasing, decreasing. When we get to 0, it starts increasing again, right? That's going up. So then we have 0 to 1. So decreasing is everywhere else. -2 to 0 and 1 to 3. Write the definition. Okay, this is probably the hardest part. So let's start with the lines. The first thing I do is I find the slope. So let's see, that's up 2 over 2. So that's, an m is 1. This one has a slope of 3 and 1, -3. And this has a slope of -0.5, it looks like. So now the formula I use, you know, the equation of a line and point slope is this. Since we're writing a piecewise function, how I write it is m times x minus x0 plus y0. So that's how I'm going to write this. So f of x equals. So I'm going to use, I have a slope of 1 for this first piece here, right? Pick one of the points. It doesn't matter which one. So 1 times x plus 4 plus 1. And that's from -4 less than or equal to x less than -2. It doesn't actually matter if you put equal to at the -2. You can pick either this one or the next one. The next one has a slope of -3, x plus 2 plus 3, -2 less than or equal to x less than 1. I'm going to skip the next one because it's the hardest. But, oops. That would be the -1 x 1. Oops. 1 less than or equal to x less than or equal to 3. This last one, 1/2, oops, x minus 1. You could have used the other points also. I could have used the 3, -1. So what is this middle, what is this thing? This is a half circle. If I extended it, that's a circle with radius 1 centered at 0, 0. The equation of that is x squared plus y squared equals 1 squared. So y squared equals 1 minus x squared. Y equals plus or minus the square root of 1 minus x squared. Since it's the bottom half, we're going to use the negative. So it's negative the square root 1 minus x squared. We use that equation a lot in calculus, like all the time. So get used to seeing the square root something minus x squared. All right, rough graph. So again, this is a line. We already found the domain and range of these. So 4, 2. There's my point, my starting point, slope of 5. It's just a sketch. Don't go crazy with it. All right, my square root, -9, -4. We talked about this one, the domain, all real numbers but -5. So at -5, there's my vertical asymptote. And at 1, I have a horizontal asymptote. This is terrible looking. I'm sorry, guys. And then looks like that. All right, so this one, I said the domain was 0. If you plug in 0, you get -3/5. So we start here. At 25, we have a vertical asymptote because that'll make the bottom 0. So this one looks like this. It also has a horizontal asymptote at 0. Oh, you know what? I messed up before. The domain, or the range, is all real numbers except for 0. Because it won't hit 0. You can't set that equal to 0 and solve. All right, absolute value. So over 7, up 2. And that is a -3/5, so it's just an upside down V. And then remember, we found the vertex before. It was 1/3, 14/3. So that's like here, and it's upward facing. I'm not going crazy with these because as long as you have a decent memory of what these look like, it's really knowing what they look like approximately. We don't have to get crazy with it. You're never going to be asked. We barely do any graphing. I'm not going to say never. We do a little bit of graphing, but it's very much, okay, sketch this so we know really what it looks like. All right, plug in. This is super important for even not our first unit, our second unit. So 2 times 25 minus 3 times 5. I'm very happy for you to skip steps. I don't care. Just get the answer. All right, so this one, be careful here. This is a really important topic. Like, we do a lot of this, so knowing how to do this and doing it quickly is important. X squared minus 7 is x minus 7 squared is x squared minus 14x plus 49. So that's 2x squared minus 28x plus 98. And then we have the minus 3x plus 21. Gives me 2x squared minus 31x plus 119. And then this one, we're going to do a lot of x plus h's. It's the same idea. So if you multiply out x plus h squared, that's x squared plus 2xh plus h squared times 2. So we get 2x squared plus 2, or, just kidding, 4xh plus 2h squared minus 3x minus 3h. That's your answer. It's ugly, I know it, but deal with it. We're going to be using that later, and so it's an important skill to have, being able to multiply all that out correctly. All right, last problem. A Shell station stores its gasoline. I forgot to fix this again. This is supposed to be an H. I keep forgetting to fix that edit. A Shell station stores its gasoline in an underground tank that is a right circular cylinder. So we got a cylinder. We do lots of stuff with cylinders. Lying on its side. Just kidding. It's this way. The volume of the gasoline in the tank in gallons, so the volume is in gallons, is given by the formula V of H, where H is inches. If H is 12, how many gallons of gasoline? So this looks super complicated, but it's not. They're giving me inches. H is inches. We're just plugging in 12. So we just need to accurately be able to plug this in. So 40, 12 squared, 144, the square root, 96 over 12 minus 1.608. And 96 divided by 12 is a nice number. That's 8. Where's my calculator? All right, so we got 40 times 144, the square root of 8 minus 1.608. And I get 14,562.665. 3 decimal places. Oh, that was so ugly. Hold on. 14,562.665. Always give me 3 decimal places. Always. If h is 1 inch, 40, 96 minus 1.608. Again, just plugging in. 1.608. Let's see. 388.622. And we're done. All right. All right, here's your first homework. Again, it's just review of domain and range in general. All right, so we're doing like 3 or 4 review lessons. This is the first. I know it was long. I'm sorry. I promise the other days won't be as long. See you later. Email me if you have questions.